So, last one. We're building some kind of, it's a rectangular prism. So, that's going to look something like this. Okay with that? And they're telling us that the top is open. So, it's not necessarily going to be a cube. Mine looks a little bit like a cube. But we do know that the base, so let's label our variables here. The base is square. So we don't have to worry about length, width, and height. We just got to worry about basically width, and height, if you think about it like that. So if this is W, then this has to be W, and this has to be H. Let me get that picture. Make sense? Well, okay. And they want us to minimize the amount of material we use. That's the same thing as minimizing what? Surface area. Yeah, we just want to minimize surface area. And the surface area of this box, so surface area is just, if you don't remember, it's all the areas, all the faces added up. So the bottom has an area of x squared, or w squared, and then each side has an area of w times h, and there's 4 of them. 4wh. And there is no top. It says it's an open box. Okay? So same thing, these very, very similar problems here in that like you always have to get rid of a variable so far. All right, so we are going to have to derive this eventually, but we got to get rid of one of these variables, and that's based on some kind of restriction. And the restriction was that our box has to hold 500 cubic feet. Okay, so that's a volume. The volume of this box is 500, and the volume of the box has to fit this equation. W times height. Okay, so it's easiest to solve for h here. H is going to be 500 over w squared. What's wrong, guys?
Why wouldn't you do, why did w squared? Wouldn't it be
LWH, you mean?
Yeah, how do you know it's...
Oh, it says in there that it has a square-based open-top box. So if we had an L in this case, if the length could be changed as well, this is a much more complicated question. Because then we got 3 variables, we got to get rid of them. That's going to be a little bit tougher. Okay? So usually in a question like this, they'll say the base has to be a square or the sides have to be square so that you don't have 3 variables, you only have 2. Okay? But now that we know the height is 500 over w squared, because the volume has to be 500, we are just going to go ahead and plug that in here for h. And that's going to give us the surface area has to be w squared plus 4w times 500 over w squared. And when we simplify that bad looking thing down, we are going to get w squared plus, so we get a w canceling over here, it's going to be 2,000 over w. Whew. And that's our surface area equation that we want to minimize. So we're going to derive it, find where it's 0, make a number line. Right, Giggles? We good back there? Yeah, things are good. All right. We get ds, dsa, whatever, over dw is going to be 2w. The same rule happens here. You get negative 2,000 over w squared. And then what we got to do, we got to set it equal to 0, and to solve that, we're going to have to well, not factor. We're going to get a common denominator. Don't just move it over. Let's get a common denominator.
But you can move it over too.
I know you can move it over.
That's like the easiest way.
It is. But when we're finding increasing, decreasing, you lose that 0. Okay, so just get used to getting a common denominator. And the common denominator is going to be w squared, and that makes this a w cubed. So what we're going to get is 2w cubed minus 2,000 over w squared. Cool. So in terms of, if we had to find where it's increasing and decreasing, we get 2 magic numbers here. The first is 0, because that makes the denominator 0. And the second is going to be the cubed root of 1,000. Okay, and that's 10. So we get w equals 10 is our only viable answer. And that's going to be our answer, but we can check just by making our little number line. If we plug a number in between 0 and 10, like 2, you're going to get a negative over a positive, so that makes it negative. And you plug in a number bigger than 10, like 20, you're going to get positive over positive, which is positive, which means our surface area equation must be decreasing and then increasing. So it's at a minimum at 10. Okay? And this question says, what dimensions do you tell the shop to use? Well, we want W to be 10. What? Calm yourself down. We want W to be 10. And if W is 10, from our equation up here, the height has to be 500 over 100, which is 5. And that's in feet. And just to reiterate, if you're asked to explain why or justify why you know there's a minimum, all you need to say is there's a minimum when W is 10 because the derivative changes from negative to positive there.